Hi everyone, I'm showing you an answer to exercise 18.1, exercise 1 from chapter 18. On Canvas, you can go over here to modules and in the recommended end of chapter problems. Well, it's sort of in lieu of a end of chapter problem. Come down to chapter 18 and click this one. This PDF, I've opened it already. Shows here. This is the data we worked with in class on November 9th. Student retention data. It's from NCES. It's for a sample of 150 Western four-year colleges and universities. So we're going to make a scatter plot. That's part A of cost of attendance as the X variable is the independent variable, and student retention on the Y-axis as the dependent variable. So does how expensive it is to live and pay tuition and everything at a college affect whether students stay? Do they transfer? Do they drop out of college because they can't afford it? Okay, so I thought that'd be an interesting relationship. Let's see. A good first step is to make a graph. Then we're going to look at autocorrelation and heteroskedasticity, and we just need the scatter plot to know at least something about those two, whether we have a problem in those two areas. And we'll think about whether a line would fit the points pretty well, or whether it's obvious that a curve or some other shape besides a straight line fits the data better. Okay, so I need one of these files. I'm going to start in Excel. On Canvas, there's my Excel file, there's SPSS, we'll probably get to that later. I've already opened it. It is this one. Okay, there it is. So we have an ID for each university, University of Utah and 149 others. There's the variables, student retention, and the cost of attendance. Insert, scatter, that one. Now, I'm going to right-click anywhere inside and go to Select Data. I'm going to remove that because they probably tried to include columns A and B and everything in there. Then I'll add my own. I'll call it something. Retention. That's just a label. It won't make any difference. And my X variable is cost of attendance. This is what I think is causing the retention to be better or worse. And my Y variable, I'm holding Shift Control down arrow to select all this. Okay. Okay. Do we have a graph? Let's go to the top. There it is. That is the scatter plot we were looking for. It looks great. So it's kind of funny shaped. It's not all in a straight line. There's some stuff up here. How do you think the line should go through this? Do you think it should be like this, like GRU? Some kind of VU? That way you could hit these points? Do you think it should be a straight line like this? Well, my answer to part C, here's a linear trend line. Like if Excel had to put a straight line on it, couldn't put a curved line, that's where the straight line would go. That's like average, the best in the middle kind of route that you can go. But I don't know. That might be nonlinear. If it were nonlinear, if it's this kind of shape, then it'd be logarithmic. So again, just watch the mouse to get that shape. It's going up steep and then it's kind of flattening out, but that doesn't explain these points. Okay, I'm going to show you what a quadratic might look like. If you wanted to catch these points and then go up like that, like a little bit of a check mark or a swish or a U or something, that would be quadratic, but that would miss these down here. It wouldn't represent those very well. Okay, I think linear is okay. My answer to part C would be, it's not very clean, but it probably is linear. I don't know. But there's no obvious nonlinear pattern that would fit real well to me. Okay. There looks to me like there's a heteroskedasticity problem. If it's homoskedastic, if there's no problem, then the distance from the line, let me see if I can find something to draw with here. Okay, see how these are way up here? And these are kind of close to the line. And these bulge out. So the errors are big over here to the left, and the errors are small to the right. That's what heteroskedasticity is, when the errors are different across different parts of the x variable. So from 20,000 to 30,000 you have big errors, and then for 50 to 60,000 you have little errors. So yes, probably we do have heteroskedasticity. What about autocorrelation? Autocorrelation's when, if you could see like certain patterns in these, like they tend to be in lines or something, they're not just randomly above and below the line, then there might be autocorrelation. There's some gaps here, like these are kind of clumped together, kind of strange that they're clumped together. Why? But I'm not real sure. I'm not really, based on this, I'm not worried about autocorrelation. If if you looking at it, it does look like it's not just randomly spread above and below the line, because it's kind of just a judgment call. You could do a Durbin-Watson test. You could find that in SPSS or a good statistics program to do a Durbin-Watson test, and to prove, or almost prove, whatever, that you probably have a problem or probably don't. Okay, I think I'm done with that question. So 18.1, I made a scatter plot. I put x on the x-axis, y on the y, and student retention on the y-axis. I am concerned about heteroskedasticity, not the other. Do I think there's a nonlinear relationship? Probably not. That's the end of this video.